Let us understand what is regular and irregular reflection, and we'll understand what is scattering of light. Before understanding this, let's come to some very basic thing, and that is reflection of light. Now, to understand reflection of light, let us say here we have an opaque surface. What is opaque surface? A surface through which light cannot pass. On this, a ray of light is incident, and let us say this incident light is PQ. So actually, PQ is supposed to travel this path, but PQ reflects, and this is the reflected ray, that is QR. At the point of contact, if I make a perpendicular, that is called normal. Always remember that whenever there's reflection of light, then always angle of incidence will be equal to angle of reflection. Now these are some very basic things of reflection of light. Now let's go further and understand what is regular and irregular reflection. Knowing that I is always equal to R. For this, reflection from a regular plane surface. Now here we have a regular plane surface. Now what happens in the case of a regular plane surface when rays of light are incident, that is parallel to each other, then the reflected rays will also be parallel to each other. So incident rays are parallel to each other and reflected rays are also parallel to each other, and this is called regular plane reflection. But let us understand reflection from an irregular surface or a rough surface. Now here I have an irregular surface. Now what happens in the case of an irregular rough surface? In this particular case, when rays of light are incident, the rays which are incident are parallel to each other, but the reflected rays go in different directions. So here you can see the rays which are getting reflected are going in different directions, and as these rays are going in different direction, we can say they are getting scattered, and this is called scattering of light. Now students, after understanding regular and irregular reflection, let us come to the basic definition. This is a definition which comes in exam for 1 mark, so let's look at this definition. When a ray of light is incident on extremely small particles, the particles deflect the light in different directions, and this phenomena is called scattering of light. Let's understand this definition more in detail. For this, reflection from an irregular rough surface, let's consider Earth. And we know Earth is surrounded by atmosphere. Now what does atmosphere contain? Atmosphere is a heterogeneous mixture of minute particles. It has smoke, it has tiny water droplets, suspended particles of dust, and molecules of air. Now all this, when mixed together, what it creates is an irregular surface. So actually speaking, the atmosphere is an irregular surface. Now here's the sun, and when rays of light come from the sun and they enter the Earth's atmosphere, they undergo irregular reflection. And when they undergo irregular reflection, this is because of dust particles. The rays of light get scattered. So there is scattering of rays. And here, when this particular rays get scattered, that is how irregular reflection results in scattering of light. So now we have understood the definition. So let's see the definition again. The definition says when a ray of light is incident on extremely small particles. Here in this particular case are dust particles, smoke surrounding the Earth's atmosphere. The particles deflect the light in different directions, and this phenomena is called scattering of light. Now students, what are the factors affecting scattering of light? The first factor that affects scattering of light is the wavelength. Now what is a wavelength? Wavelength is the distance between alternate crest and trough. Now when it comes to wavelength, in terms of wavelength, always remember violet has the smallest wavelength. So violet color has the smallest wavelength, whereas red color has the highest wavelength. Now in the increasing order, a slightly higher wavelength is indigo, slightly higher wavelength is blue, next is green, next is yellow, and next is orange, and lastly we have red. So students, red color has the largest wavelength and violet color has the smallest wavelength. Now in terms of wavelength, a red light wavelength is 1.8 times blue light. So you can see the big difference or the big shift in the wavelength. Now what happens because of difference in wavelength? The color which has smaller wavelength, the scattering is more. Whereas the color whose wavelength is more, the scattering is less. So in this particular manner, the wavelength, it affects scattering of light. So from this we understand violet light will be scattered the most. Next will be indigo, next blue, green, yellow, orange, and red. Now this was the first factor. The second factor is size of particle. It means the size of dust particles in the atmosphere. Now, in case of size of particles, small particles or very fine particles mainly scatter violet light, right? Now, if these particles are slightly large particles, so if particles size is a bit large, it can also scatter red light. Now, this is a particle which can scatter red light. But if there is bigger particles, then a bigger particles can directly scatter white light. So students, two important factors which affect scattering of light is wavelength and the size of the particle in the atmosphere. And this was regular and irregular reflection and scattering of light. Thank you.